In the last section of Chapter 7, we're going to talk about geometric sequences. So by the end of this lesson, you should be able to think reasonably to discover and continue a number pattern. We're going to remember arithmetic sequences that we did in Chapter 5. You should be able to form geometric sequences and then use the formula for geometric sequences. So let's remember what a sequence is. It's just a number pattern. So if I give you something like 2, 4, 6, 8, I'm sure you could figure out the rest of the pattern. You could continue it. This is an example of an arithmetic sequence, and we form arithmetic sequences by adding a fixed number to each previous term. So in this example here, I was adding a positive 2. But we could also have something like 8, 6, 4 by adding a negative 2 to all of these, and we could continue making the sequence. This thing right here that we are either adding or subtracting is called our common difference. So remember, we've already talked about all of this stuff before. We have mentioned arithmetic sequences, we've talked about common differences, so this is the new stuff. A geometric sequence is a sequence formed by multiplying a fixed number to a previous term. So the only difference here is that we are multiplying. So if I give you something like 2, 4, instead of 6, it's got to be 8, and then we'll have 16, and then we'll have 32, and we could continue this forever. And this is formed by us multiplying by 2 to all of these things. And that thing that we're multiplying, instead of being called a common difference, is called a common ratio. So if we think back to arithmetic sequences, I gave you things like this, where you had to find the common difference, so 11 to 23 would be 12, and double check that it works for all of these, and it does. And then you had to use this formula right here. So I could use this formula to find absolutely any number that I wanted to. So I plugged in my first term, which was 11. I plugged in my common difference, which was 12. And then we had to do some distributing. And we would figure out this right here. And this would make it a linear equation. And remember, this number right here, the 12, is our common difference. But this number right here was always our 0th term. Because remember, if we were to put this into a table, we would have our first term is 11, our second term is 23, our third term is 35. So if we ever wanted to write an equation, we need the term that comes before it. So we would subtract 12, and that's what we end up doing here. The new stuff is almost exactly the same, except you're going to notice a common ratio. So instead of saying, what do I add or subtract, what do I multiply by? So if you get stuck, like this one's kind of tough to figure out what I would multiply by, remember you can always go backwards and you can always divide. Divide, not subtract. So if I do 150 divided by 750, I end up with 0.2, or 1/5. And then make sure it's the same thing here. If I do 150 times 0.2, I should get 30, and I do. And same thing with this. So my common ratio for this one is 0.2, or we could say 1/5. Same thing. This one here is a little easier to do in our head. So to go from -3 to -6, I have to multiply by 2. -6 to -12, I got to multiply by 2, and we can keep going. So for this one, the common ratio is 2. So here's your formula for geometric sequences, and it's no surprise that these ones look like an exponential function. That's why we do them in this section. So remember, our exponential function looks like this. So this is our first term. This is our common ratio, is what we're going to put in here, and then we're going to change this guy. Instead of x, it's going to be n minus 1. So when we plug this in, we're going to have to use our rules a little bit. But let's find the first 6th and 12th terms of this sequence. So our first term, we would plug in 1 for n. So I have a of 1 equals 4 times 3 to the 1 minus 1 power. 4 times 3 to the 0, which is just 4 times 1, or 4. So our first term is 4. Our sixth term, we're going to do exactly the same thing. Our sixth term is n equals 6. So we can plug this in. We'll have 4 times 3 to the 6 minus 1 power. This gives us 4 times 3 to the 5th. 3 to the 5th is a big number. It is 243. And if we multiply that by 4, we end up with 972. Now I know this asks for the 12th term, but I want us to find the 0th term. And the thing that is cool about this is when you find the 0th term, your n equals 0. So when I go to plug this in up here, we get 0 minus 1, which gives us 3 to the negative first power, which is really 1/3. So the 0th term, or the y-intercept, where this is going to cross, is 4/3. So just like everything that we did with the algebraic sequences, we can do with the geometric ones. We just have to know our rules. So you'll get questions like this on your quiz where I give you a sequence and you have to tell me if it's arithmetic or geometric. Basically what I'm asking you is kind of what you did today. I'm asking you, is it linear or is it exponential? So we sit and look at our terms. To go from 2 to 4, I can either multiply by 2 or add 2. So let's check this one. To go from 4 to 6, I can't multiply by 2, but I can add 2. And this one, I can also add 2. So this is arithmetic. And if I wanted to come up with an equation for it, I can plug stuff into the formula that we saw in the earlier slide. It's your first term plus n minus 1 times your common difference. And if we do some rearranging, some distributing, we end up with 2n. So that will give us any term we want, just 2 times n. Now this one starts off exactly the same. To go from 2 to 4, I can either multiply by 2 or add 2. And then to go from 4 to 8, I can't add 2, I have to multiply by 2. And same thing from 8 to 16. So this one's geometric, which means I'm going to make an exponential function. So if we remember the formula, this formula is new, but it's still your first term times your common ratio, and then it's n minus 1. And I know we don't do much with this here, but we're just going to leave it like this, because technically we can split this up into this. And this right here can be simplified to 1/2. And if you multiply your numbers together, you get 2 times the 1/2 times 2 to the n power, and those cross off and give you 1. So this is technically, this is technically your equation, but we're just going to leave it like this. So the next one, arithmetic or geometric. So to go from 1 to 3, I can either multiply by 3 or add 2. Here, multiplying by 3 doesn't work, so it's got to be the adding 2. It would be arithmetic. So when we plug it into our equation, we end up with our first term plus n minus 1 times our common difference. We'll do a little bit of distributing. We'll simplify, and we'll get 2n minus 1. So you should be able to do that with these guys right here, and I want you to also write their formulas. So write an equation. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.